Welcome to AI Geek. Today we're gonna learn about machine learning tutorial, overfitting versus underfitting, bias versus variance. At the end we will learn how we can identify which model is overfitted or underfitted or which model is a fit model. Let's start with bias. We will see the definition. Bias measures how inaccurate the model prediction is in comparison with the true output. It is due to erroneous assumption made in machine learning process to simplify the model and make the target function easier to learn. High model complexity tends to have the low bias. Low bias means fewer assumptions about the target function. Some examples of algorithms with low bias are KNN and decision trees. High bias means more assumption about the target function. Linear regression would be the good example of it. Having more assumption can potentially miss important relation between features and the output and cause underfitting. Next, variance. Variance measures how much the target function will change if different training data is used. Variance can be used by modeling the random forest in the training data. High model complexity tends to have a high variance. As a general trend, parametric and linear algorithms often have high bias and low variance, whereas non-parametric and non-linear algorithms often have the low bias and the high variance. Low variance indicates changes in the training data would result in similar target function. High variance indicates change in training data would result in very different target function. For high variance, the algorithm would be SVM support vector machine. Our next topic is overfitting. Overfitting refers to the situation in which model fit the training data very well but fail to generalize to the new data. Underfitting. Underfitting refers to the situation in which model neither fit the training data nor generalize to the new data. As we can see, we have three models: underfit, fit, and overfit model. Underfit model, in the simply we can say it's even not fulfill the basic requirements or not even fulfill the basic pattern in the data set. We have a linear regression model, so it's only touch the three dots or three data points in this visualization. This model failed to detect the right pattern in the dataset. But when we compare to the fit model, this line maximum touched the points. It's touched the maximum point. And when we see the overfitted, our model touched the every point. By the bias and the variance, it's a highly biased and the low variance. It's an equilibrium, low biased and low variance. And the third, it's a low biased and high variance. The next we can see with the ROC curve, the underfitted model neither perform on the training and nor on testing dataset. We'll see the performance of the model 55% on the training and 50% on the testing. It's our underfit model. Whereas compared to the fit model, the training accuracy area under the curve is 87% and the testing area under the curve is 84%. It's our fit model. The overfit model, the training accuracy is very high, 87%, but as compared to the testing accuracy, when we reach on the testing, it's low. It's drastically collapse. It's only 45% of it. So this, by the ROC curve, we can recognize either our model is fit, underfit, or overfit. Thank you for watching. Subscribe AI Geek for more content.